Hello students, welcome back to your channel at Tech Guruji, and the series we are doing is Vigyan Ka Gyan. The topic today we are discussing is scalars and vectors. This is 11th standard topic and today is part 4. Now this is also very beneficial topic for students who are preparing for medical and engineering entrance exams. So students, we are going to continue with types of vectors today. The previous 3 parts are already there on the YouTube channel. If you haven't watched those, please have a look and then watch this particular lecture. Okay, so without any further delays, let us begin with the class. The first vector today what we are going to discuss is called as null vector. Okay, now what do you mean by null vector? Null, okay, this means 0, which does not have any value. So what is a null vector? Such a vector whose magnitude is 0 is called null vector. Its direction is arbitrary, that is, it is not specified. Now, why this concept came into existence? See students, if we have two vectors whose magnitudes are same. So, if we have a bar and b bar and the magnitude, matlab mod of a bar is equal to mod of b bar, then a bar minus b bar will give you a null vector. Okay, so its magnitude is 0 and its direction is arbitrary. Now, moving ahead with the next type of vector, it is called as a unit vector. Again, the name is unit vector. That means something to do with unity. Okay, unity. So, a unit vector is that vector whose magnitude is unity. That means its magnitude is 1. Okay, so such a vector whose magnitude is unity is called a unit vector. Now, this vector is very important to you all, very important. Okay, I would say I will keep on reminding you about this particular type of vector, very important for everyone. Now, what is its importance? See students, we know that any vector, let us say we have a resultant vector, okay, which is r bar. Any vector will have two things. One is magnitude and one is direction. So when I am writing a unit vector, okay, unit vector, that means I can say this vector r has two things. One is its magnitude, which is mod of r. The other thing will be its direction. So any vector when given in unit term, unit vector, okay, it only is giving you the direction of that vector. Then I can say I can multiply this magnitude by the direction. So this is my unit vector with a cap. So no arrow now. Okay, there is a cap. So this is giving me the direction and this is giving me the magnitude. Okay, this is my magnitude and this is my direction. So what is the importance of this? See, I can convert any scalar to vector by giving it a direction. You will say, sir, what does that mean? What I mean to say is, let us say I give you a distance. Okay, for example, I will give you a distance. I will say that there is a distance, okay, there is a distance of 20 meter. This is a distance. What is this distance? Distance is nothing but scalar. Distance is scalar. Now, if I give this distance a particular direction, it will become a vector. That means what will it become? It will become a vector displacement. So, how will it become a displacement? When I will say that this 20 meter is towards east, So I have given it a direction. Now this direction in vector we have some conventions. Okay, what are the conventions? Okay, is this clear to you? Okay, I can similarly say speed is a scalar. I can give a direction to speed, it becomes a vector which is velocity. So likewise what I meant to say is importance of unit vector. One of the importances I can convert any scalar to vector by multiplying the scalar by unit vector. Okay, now let us say the convention. The convention is, if I have an origin here, okay, and let us say this is my x-axis. So here I have my x-axis, this is my y-axis. Okay, so this is my y-axis and here is my z-axis. Okay, so this is my z-axis. Now we say that a unit vector along x-axis, a unit vector along the x-axis is given by I cap. Okay, I cap. That means if this is positive x-axis, so the unit vector along positive x-axis is given as I cap, I cap, and this will be the negative of x. So negative x-axis पे क्या होगा? Then it is going to be minus I cap. Okay, minus I cap. Importance, I'm just going to tell you what is the importance. Likewise, for y-axis, okay, this is my positive y-axis. This is my positive y-axis. So unit vector along the positive y-axis will be given as j cap. Okay, it's all small I, small j. Okay, so this is given as j cap, and this is my negative y-axis. So here my unit vector will be minus j cap. Okay, this will be minus j cap. Likewise, along the z-axis, 3-dimension, maximum you will get a 3-dimensional system. Okay, so in 3-dimensional, the z-axis, this is positive. Okay, so this is given as small k cap. Okay, and this is my negative z-axis, so this will be given as minus k cap. Okay, so now these are my convention, that a unit vector along the x-axis is I cap, along the y and z axis is j cap and k cap respectively. If it is positive side, it is plus. If it is negative side, then it is minus. Okay, now how does this really help me? What is this importance here? Okay, the moment I said that the displacement is 20 meter towards the east, so now we have the direction sense already in mind. Okay, suppose this is my xy plane. Okay, so this is my xy plane, this is xy plane. So now I know that this is north, this is east, this is west, and this is south. Now if I am saying 20 meter towards the east, that means this direction. What is this direction? Is x, positive x. So I can rewrite this in terms of unit vector, that this displacement is nothing but, okay, this displacement is nothing but 20 I cap. Okay, 20 I cap. So this 20 means I am moving 20 units towards I cap, means towards positive x-axis, and positive x-axis per students kya hai? East hai mera. Okay, so this is another importance of my unit vector. Okay, we have some more importance. Okay, some more importance which we will learn little later. This helps me in calculating vectors. Okay, when we have more than one vector, we can do some calculation how we do it in normal algebra. So that is something which we will deal with little later. So as I said, I will keep on reminding you about this unit vector. It is very, very important. But for now, you have to understand, okay, that any vector has a direction, and the direction can be given as a unit vector, and this is the magnitude. So in another way, I can say that a unit vector is what? A unit vector is nothing but when a vector is divided by its magnitude, you get a unit vector. This is how also we can calculate the direction of a unit vector. When you divide the vector by its magnitude, the resultant is your unit vector. So I hope that this is clear to you. Let us move ahead towards the next type of vector. Very important, I told you in the last class itself that these vectors, what we are going to discuss in today's class, are very, very important for all of you. So null vector is also very important. Unit vector is having a lot of importance. Okay, moving ahead, what we have, the next vector we are going to discuss is called as a position vector. Very important, again, something we discussed yesterday, a localized vector. Just relate with the position vector again. Okay, now what is a position vector? Position vector, so the position vector is a vector which tells where an object is relative to a fixed origin. In simple words, it is that vector which gives us the position of the particle from the origin. Such type of vector is called position vector. So let us say we have a plane. So here we have our origin. Okay, now from this origin, once the plane is defined, now I can't change my plane because it is now a localized vector. Okay, position vector is like a localized vector. It is a vector which is giving me the relative position of the object with respect to a fixed origin, localized. Okay, now if there is another point P here, okay, there is this point P here, so this is my point P. Okay, one thing is I can give you the coordinate of this point in terms of x and y, because see, this is my x axis and this is my y axis. Okay, so the coordinate is given in which terms? It is given in xy coordinate term. Okay, पहला वाला जो नंबर होगा वो x axis के कोऑर्डिनेट को रिप्रेजेंट करेगा, दूसरा वाला y. अगर 3 डायमेंशन होगा तो x y z. ओके, ये कन्वेंशन है सारा. तो अब अगर मुझे x कोऑर्डिनेट, तो x कोऑर्डिनेट स्टूडेंट्स क्या होता है? आई एम श्योर दैट यू नो इट, बट व्हाट इज x कोऑर्डिनेट? X coordinate is basically the perpendicular distance of the particle from the y axis. So this becomes my x coordinate. This becomes my x coordinate, right? It is the perpendicular distance of the particle from the y axis. Likewise, what is y coordinate? This is my y coordinate, which is the perpendicular distance from the x axis. उल्टा होता है, कंफ्यूज नहीं होना है. What is x coordinate? The perpendicular distance of the particle from the y axis. What is y coordinate? The perpendicular distance of the particle from the x axis. So यहाँ पर हो गया मेरा x और y. अब let us say this is 1 unit. Okay, that one big square what you see is 1 unit. So currently I see that my x coordinate is how much? 1 2 3. 1 2 3. Okay, and what is my y coordinate? My y coordinate is the perpendicular distance from the x axis. So again it is 1 2 3. So that means this position is given 3, 3. That means my x coordinate is also 3, my y coordinate is also 3. This is the current position of my particle with respect to this particular origin. Now if I change my plane, I am not changing my position. Okay, understand, that is why I don't change the plane. Okay, because if the plane is changed, my position vector will change, because this is the point of reference from where I am seeing the system. Okay, if I change this plane, let us say, okay, currently this is my position vector which I give as OP vector. Okay, OP vector, OP bar. Okay, O to P. If I change my plane, let us say here is my new y axis and this is my new x axis. So here I get the new origin which is O dash, this is x dash and this is y dash. Now the point is still at the same place where it was earlier, but now I have changed my reference. My origin has been changed. Okay, so now this is my x coordinate, okay, which is more. Now it is another, say, we have already counted 1 2 3. Now this is 4 5 6 7. So now 7 units. Okay, 7 units is my x and here is my y. So we already have 3, then this is 4, this is 5. So now the position vector, which is this, okay, this yellow one, which is now I will say it is O dash P bar. O dash P bar. P is the same point, O dash P bar. So now if I am standing at this particular point, I will say that my coordinates of this position point P is 7, 5. 7, 5. But has this point P displaced? No. So that means the position vector will change. Okay, a note here. What does this mean? Position vector will change if plane is changed. Okay, position vector will change if plane is changed. So my earlier plane was xy, the new plane was x dash y dash. Okay students, is this getting clear? So position vector is very, very important. It is a vector which tells me about the position of the particle from the origin. And once we define the origin, in the question we will not change the origin, because if the origin is changed, the coordinates will change. If the coordinates will change, the values will change. If the values will change, our answer will come something very different. So once we take a plane, we can take a plane anywhere. I could have taken xy plane, I could have taken x dash y dash, but once the plane is taken, then we will not change the origin, because any other particle on that plane will be measured from that origin itself. So I hope that this is clear to you. Okay, so let us move ahead towards displacement vector. Now, what is displacement vector? Basically, it is defined as the change in position vector. Okay, so when a particle changes its position in a given plane, okay, its position vector changes, and that change in the position vector is what is called as a displacement vector. Okay, so let us say this is the plane which we are going to consider for today's class. This is my origin here. Okay, this is the x-axis, here is my y-axis. Now let us say we have a particle at this particular point. Okay, let us say this is r1 vector, which is my position vector. Okay, so this can be given as r1 vector. Okay, I can also say this point is my point P. Okay, so this is OP bar or r1 bar. What is r1 bar? Is nothing but OP bar. You have understood now what is its x and y coordinate. I can also give its xy coordinate. 1 2 3 1 2 3 4. So 3 comma 4 is my current position. In terms of unit vector, I can also say it is 3 I cap comma 4 j cap. Okay, I hope this is clear to you. Now I'm saying after some time the position of this particle changes. Okay, the particle is the same. Okay, but this particle now comes to this point. Okay, so this is now a new point, which is point Q. Okay, now current position is 1 2 3 4 5. Okay, so this is 5 I cap comma 1 2 2 j cap. Okay, so now this is also given as R2 bar. I can say this is R2 bar, OQ bar. So what is R2 bar? It's a new position vector, which is OQ vector. Okay, and these are my coordinates, 5 I cap and 2 j cap in terms of unit vectors. So now the body has displaced. The body has displaced from point P to Q. So displacement is the distance between the initial and the final point. So this is going to be my resultant vector. Okay, so this is my resultant vector, which is capital R. R bar resultant. Okay, which is directed from P to Q. Okay, so this will be given as final minus initial. That means OQ bar minus OP bar, or I can say R2 bar minus R1 bar. So this is going to be my resultant vector. So the resultant vector here, R bar, is nothing but R2 bar minus R1 bar, and keep this diagram very clearly in your mind. We will discuss about this diagram more later on. Okay, so this is how I calculate my resultant vector. Final vector, final position of the given particle, okay, minus the initial position of the given particle. Okay, so this is how I can give it. Now the importance of unit vector I was telling you. So let us consider here the particles are the P and Q positions are given to you. Okay, so now what is R2? Okay, so I can calculate the coordinate of my resultant. Okay, I'm just giving you this example here only. Okay, so R2 bar, R2 bar matlab this one. So this is 5 I cap plus 2 j cap. Okay, minus R1. R1 is 3 comma 4. 3 I cap plus 4 j cap. Okay, now I cap together, j cap together. As I said, it will give me normal algebraic addition and subtraction. So this becomes 5 I cap minus 3 I cap plus 2 j cap minus 4 j cap. So now this becomes 5 minus 3. That means my answer becomes R vector in terms of unit vector will be 5 minus 3, 2. 2 I cap plus 2 minus 4. minus 2 j cap. Okay, so that means finally it is 2 I cap minus 2 j cap. So this is my final coordinates of the resultant vector. So this is how unit vector helps us. So I hope that the displacement vector is very clear to you. Okay, now one additional, okay, additional point. Okay, a very simple name I am telling you. Okay, I, j and k. Okay, if this is I cap, this is j cap, and this is k cap, all three are perpendicular to each other. Okay, I, j and k. So such vectors, okay, who are perpendicular to each other, any two vectors when they are perpendicular to each other, they are called as orthogonal vectors. Okay, orthogonal vectors. So orthogonal vectors are such vectors which are perpendicular to each other. This was the additional point. So I hope that today's class is very clear to you. The null vector, unit vector, position vector and displacement vector. Okay, in the next class, students, we will study angle between the two vectors, and also we will introduce you to vector algebra. Yes guys, now we will start actually how we calculate vectors. Okay, how do we add, how do we subtract, how do we multiply, and so on so forth. So till then, stay tuned to the channel, subscribe to the channel if not already, like the video, share the channel and the video with all the students in your connect, so that all students across can get benefits of these video lectures. With that positive note, this is your EdTech Guru signing off. Happy learning. Take care.